Ladies and gentlemen, good evening. My name's Chris Blackburn. I am one of the university's Pro-Vice Chancellors, and I'm Dean of Oxford Brookes Business School. And I'm delighted to welcome you here this evening to the open lecture being given by Professor Julian Bayliss, entitled Journey of Discovery, Ecology and Exploration. I was just given Julian's card, and I've always wanted a business card like this. It says, Professor Julian Bayliss, Explorer. You can't get better than that, can you? Julian Bayliss is an Oxford Brookes alumnus, having graduated in 2003. He's, as I've said, an explorer and an ecologist, and he organises and runs scientific expeditions to some of the world's most remote areas. Over the past few years, as well as discovering the largest rainforest in southern Africa, he just happened to come across a mountaintop forest in Mozambique, which scientists believe has never been disturbed by humans. In remote regions such as these, he has discovered more than 20 new species. When not organising scientific expeditions, Julian is involved in protected area management and combating wildlife crime in Africa. In his talk tonight, Julian will examine the role of modern scientific exploration in assisting conservation work in Africa. He will also focus on the technological tools at our disposal, which weren't available to, it says in my script here, explorers of old. As well as demonstrating how these tools are used, Julian will share some of the discoveries that have resulted from them on his expeditions. He will also highlight the dangers and discoveries from a series of scientific expeditions over the past 10 years and show how he has applied the skills he learnt doing his PhD here at Oxford Brookes to his, quite frankly, remarkable work as an ecologist and explorer. So, we're delighted to welcome Julian back to Oxford Brookes this evening to talk about the journey of discovery, ecology and exploration. And could I ask you to join me in giving Julian a very warm welcome?
Thank you very much, Chris. Well, it's an absolute pleasure to be back at Oxford Brookes. I spent 4.5 very happy years here. With many happy memories, and it's very nice to see some familiar faces in the audience. It was a few years ago now. So anyway, I hope you'll find the presentation tonight interesting. And there is a connection here between the skills I learned at Oxford Brookes through my PhD and how I've taken these skills and I've applied them to the work I do in Africa, which, as Chris was saying, is basically conservation management, exploration, and also aspects of wildlife crime. So without further ado, the title of my talk is Ecology and Exploration, the use of technology and scientific exploration and wildlife crime in Africa. A little bit of background. I have a first degree in zoology, a master's in conservation biology, and my PhD from Oxford Brookes. That was titled The Use of GIS Geodesistics and Multi-Level Modelling for Biodiversity Action Planning, and that was under the expert supervision of Professor Stuart Thompson and Dr. John Lee. This involved the use of spatial relational databases, remote sensing, and biodiversity action planning. Post-PhD, I've been working in Africa in protected area management, the creation of new protected areas, wildlife crime, organising scientific expeditions to previously unvisited mountains by biologists. In that sense, I'm regarded as an explorer. When you think of an explorer, images such as these are often conjured up of the golden age of exploration, with big long lines of porters carrying supplies through rivers, streams, across rickety bridges, up the sides of mountains. And even today, much of that is pretty much the same. You'll find long lines of porters carrying supplies up mountains, through rivers, across rickety bridges, etc. So what has changed? Not that much in terms of the everyday experience of being, for example, out in Africa and running a scientific expedition. We still take our vehicles to the ends of the road, where we go in ends of the road, being a village. We go and see the local chief. He then organises the villagers into porters, and off we go. We trek up the sides of mountains to forests, where we make a camp. Essentially, equipment such as butterfly nets and plant presses, bat nets, are all essentially the same. And a lot of the dangers are still the same, such as malaria, snakes, for example, rickety bridges, if I want. All of these things are very similar to what was experienced maybe 100, 150 years ago. So what is new? Well, a lot of taxonomy has changed, especially in the last 20 or 30 years, certainly with the introduction of DNA sequencing. This is now the sort of benchmark for determining whether a species is new or not. We use a lot of remote sensing through the use of satellite imagery. This enables us to look down on wide areas and to focus in before actually going in the field or on the ground and seeing with your own eyes. We use geographical information systems, which are spatial relational databases, global positioning systems, drones, helicopters, and camera traps. And in this talk, I will show you and demonstrate how these have been applied to my work in Africa. A lot of these are certainly remote sensing, satellite imagery, geographical information systems were fundamental to the PhD I did here at Oxford Brookes. Let's have a look at a map of Africa. The red square is where I work. This is northern Mozambique and southern Malawi. If we look to the right-hand side, we can see a terrain map, a digital elevation model, which shows basically all of the mountains labeled where I've been running expeditions. Mozambique has a bit of a checkered history, unfortunately a violent past. It went through a protracted war of independence and then quite a bloody civil war after that. And as a result, the remains of these conflicts are still scattered around the countryside, and you come across them on a fairly regular basis. A lot of landmines were there for quite a long time as well, and that was also a bit of a danger. But I work in the mountains. I work in the Inselbergs, which means island mountain. These are generally very old in origin. The ones I work on are 500 million years, give or take 100 million years. And they're made of granite, which is an igneous rock. This was molten below the ground, and as it was formed, or as the tectonic plates came together, they forced the molten granite up through the softer rock, the metamorphic rock, to create these granite domes that we see now. An Inselberg, by definition, is a hard piece of rock that's been exposed through the weathering of the softer land around it, thus exposing it. As these mountains are old in origin, the forests or the grasslands that we find on top of these mountains are also fairly old, and the species associated within those forests have had plenty of time to speciate and to form new species. Therefore, they have high levels of endemism and because of the conflict that's been occurring in northern Mozambique, have been relatively unexplored until recently. One of the most famous of these is Mount Malangi in southern Malawi. This is the second highest mountain in southern Africa, rising to over 3,000 meters. It is thought to be one of the, or not the, inspiration for Tolkien, because Tolkien walked across Mount Malangi before he wrote Lord of the Rings. And Mount Malangi, with its 20 peaks and a 450-kilometer square massif, would be akin to Mordor in the books. And running down the southern part of Malawi, we have the Shiri River, bringing water to the fertile grounds, which might have been the inspiration for the Shire. If we have a look at some of the maps of the area which I work in, on the left-hand side, you have a map that was made in 1887. This was made by J.T. Last. He was an explorer for the Royal Geographic Society. The map on the right is from Google Earth, made in 2017. If we compare the two, we can see that they're actually fairly similar. So the map made in 1887 is also fairly accurate today. So it's not necessarily true that, just because we have all this modern technology, the stuff that was made, many, many years ago or 100-odd years ago is redundant or not that accurate. The map on the left-hand side was made with sort of hand-held devices, and the map on the right came from a satellite image. J.T. Last, like I said, was an explorer for the Royal Geographic Society. In 1887, he wrote, as he went through northern Mozambique, it was a time of man-eating lions and cannibalistic natives. As we went along, the people came out with a great noise, and the chief sang out that he wanted my helmet to wear and my skull to use as a drinking cup. I did not agree with him on that subject. Coming to the first of our technological tools, I use these a lot. This is a camera trap. The beauty of a camera trap is it can basically record animal movement when you're not there. It is a form of remote sensing for studying animal behavior. If you're in a forest, especially a rainforest, most of the animals, if not all of the animals, will hear you coming because you make a lot of noise. and they'll run. You'll never get to see them. So you'll see very little animal life in a forest, in a wet forest. Camera traps have come on leaps and bounds in the last 10, 15 years. 15 years ago, they were these big, heavy things that you had to sort of align up with a big beam that may or may not be broken, and you had to carry them up, and they were heavy things. Now they're small, compact, very efficient. You put 8, 10, 12 AA batteries in, and they can last for a year, sometimes 2 years, depending on how you set them. Waterproof, and they're very similar to the security cameras you might have around your house. They're basically motion sensing. When something moves, it records a photograph or a video. Here's some elephant footage from one of the mountains I've been working in. Oh, all right, there we go. And some leopard footage. Again, some of the camera traps I've been using on some of the mountains. The leopard on the right-hand side very kindly decided to park off in front of my camera trap and sort of take a break from its days travelling around, and we've got some lovely imagery there of a leopard. None of this would have been possible, especially the elephants and especially the leopard, without if you were actually there in person. I actually have a camp which is about 50 meters away from these leopards, and I often stay there on my own. So generally, leopards don't attack humans or adults, so I work on that basis. Lions will. And it's not just animals we capture. Here are some poachers. This is a father and his son poaching in the same forest. He's got a gun. The man's got a gun. The son's got a machete. And here are the same father and son 2 years later, also poaching in the same forest. On both occasions, they've walked straight past the camera trap without noticing it. So I'm not quite sure how good a hunter they are. So the camera trap can be useful. It can be useful for, obviously, animals, seeing what animals are around, but also levels of poaching and things like that. Coming to the first of the sites. I'm going to show you 2 sites today. I'm not going to run through the last 15 years of expeditions. I'll show you one of the first ones, which was Mount Mabo, and one of the last ones, which was Mount Liko. Both of these sites have received quite a lot of media attention. This is my camp in Mabo Forest. It's been known as a Lost Eden, and you can probably see why looking at this photograph. It is truly an astoundingly beautiful place. And the forest, the rainforest, is in excellent condition, and it is an absolute joy and pleasure to spend time there. So that's my camp. Sites, Mount Mabo. So until 2005, it was relatively unknown. The local people knew it, and they used it, and they hid in it during the war, during the conflict times. It was a place of refuge. But to the international community, to the outside world, it was not known. And I was setting up a project through the Darwin Initiative of the UK government for Kew Gardens, and I used Google Earth to select 6 mountains, one of which was Mount Mabo. On our first visit, we had to get through the mountain through a derelict tea estate. So if you look at the top left image, that's tea. Tea, naturally, is a 30-foot subcanopy shrub. It is not something that grows to about 1 meter, which you then pluck. It's only like that because humans have made it like that. Naturally, it's up there. And so this is tea. And the estate had been abandoned in the early 80s, and the tea had just grown, and had grown into this subcanopy forest. And you actually drove through these tunnels of tea to get to the base of Mount Mabo. So on our first visit, we decided to climb up the main peak, not knowing there was a forest on the other side. We got 3/4 of the way up, ran out of water, but that day gave us just enough time to poke our heads around the shoulder of the mountain and see the start of the forest. And that forest then turned out to be the largest rainforest in southern Africa. All of this was then basically extracted from a satellite image and put down through a geographical information system. And using our global positioning systems, our GPSs, all of our routes and walking paths and everything else were then placed on top of these maps. Again, these are all skills I learned through my PhD at Oxford Brookes. A lot of new species were found at Mount Mabo. I'll show you a few pictures of those. After a few years of media attention, the BBC got in touch, and they were creating the Africa series, which came out in, I think, 2012. But in 2010, they were filming it. On On top of the summit, I discovered what was a phenomenon known as the butterfly hilltop. A hilltop, in terms of butterflies, is when thousands of butterflies all gather together for a very short time in the morning at a particular time of the year, and they all sort of interact and find mates, and then suddenly the skies disappear and everything's gone. And the BBC heard about this, and they wanted to actually include it in the Africa series. So I took a camera crew. Well, actually, it was just in Maguire, one cameraman. He came with about 100 cases of gear from the BBC, 4 massive cameras. We had over 100 porters just to bring him and his cameras up to Mabo Forest. It was quite an event. And he set about filming this. My job was to capture some of the butterflies that feature in the episode, cool them down the night before on sort of crushed ice, things you break and stuff, and then create a sugar solution that we put on moss on top of a branch on the edge of a waterfall, and then bring them out in the morning and place them on the moss. When they'd wake up, they'd feel the sugar through their feet and want to feed, and then they could film them before they took off. I don't know if I should tell you that, but anyway, there we go. So I think my proudest moment of all of that was, it was called the Google Forest, because I used Google Earth to find Mount Mabo and the forest and everything else, and then David Attenborough changed it and said it could also be called the Butterfly Forest, so I thought that was very special. New species found for Mount Mabo. We found new bat, which is obviously a mammal, so that's quite a big find, a new plant, lots of new snakes, 3 in fact, and I found the one you see in the middle by stepping on it. So this is a new species of viper, a bush viper. We named it after the forest, Atheris marboensis. I discovered it because I stepped on it. And the picture at the bottom left-hand corner is a snake after I stepped on it. So it's a very beautiful thing. As you can see, the middle picture has got lovely golden tips for the scales. The other 2 snakes, the one on the right-hand side is looking a bit worse for wear. That's actually got an affiliation with the Congo rainforest, thus proving that these forests were all linked at some point, and they basically retreated pre- or post-ice age over time. The gaboon viper, we get the gaboon viper in the forest. Now, 90% of snakes will always run away. They'll hardly ever attack you, and they'll only attack you if they feel cornered. And that's a good rule to go by. Snakes are not necessarily dangerous, even poisonous ones. The gaboon viper, on the other hand, relies on camouflage, and it just lies in the leaf litter, very quiet. It's a very docile snake. It's a very sleepy snake. It's not even an aggressive snake, but you might stand on it. And if you stand on it, it will bite you. And it's the largest viper in the world, and it's got 1.5-inch long fangs, so you don't want to do that. We didn't kill this one. We don't no need to collect this snake as far as we're concerned, but the locals brought it in, so we took some photos. Chameleons, we found quite a few of these from the mountains. I just found a new one last week. I only got back 2 days ago from Mozambique and found a new pygmy chameleon on 2 mountains that we were looking at there. These are quite special, so pretty much every mountain we go to, generally we find these pygmy chameleons. They're about the size of your thumb, not much larger, fully grown, quite beautiful little things. This was named Mazipictus, which means painted face. The one on the left-hand side, yeah, well, that was called Bayliss eye. These butterflies are also new species that I found. Quite a few of these. We're finding new butterflies on most of the mountains that we go to. After several years of people talking about the Google forest, Google finally got back in touch, or Google finally got in touch, and decided to make a short story about the discovery or the use of Google Earth in the discovery of Mount Mabo. And that came out as a series of shorts on the TV. I think a few people here might have seen it on the UK TV. And here it is.
People say that there's nothing left to discover in this world, but there are new species to be discovered, lost worlds and lost Edens to be found.
Scientists are driven by a real thrill of finding something which is not known. It could be a fact which is not known, it could be a species which is not known. Just putting your little bit into this massive jigsaw puzzle of life.
We concentrate so much on thinking about going into space and doing all of this, and yet on our doorstep, still, there's pockets of habitat that hardly anyone has been to.
Some years ago, I was working on an isolated mountain in Malawi, and I noticed there were similar mountains over the border in Mozambique. There was nothing written about these mountains. There were no biological records at all. The area was largely inaccessible because of the war and the fighting that had been occurring for the last 30 years. So when I returned to the UK, I was able to see Mount Malangi in southern Malawi, which is a site I knew very well. I was then able to look across northern Mozambique And then as I zoomed in, I saw this dark green patch suddenly emerge. That was tremendously exciting because this could be lost rainforest.
You can just see the summit of Mount Mabo coming up behind this main woodland ridge. So we just entered Mabo Forest, and immediately you can see a big difference. Look at the size of the trees.
When you enter into a forest, everything changes. The forest is cool, the canopy is high and it's very shady. Life is buzzing all around you. This is the butterfly that I stood for 2 days in the forest clearing trying to catch. Here we are. This is a juvenile Malangi Baylissi. I was lucky enough to find the first one of these. Since the main expedition, we've discovered approximately 12 new species for Mount Mabo. What medicinal use does this bracket fungi have?
That is medicinal for back.
The knowledge, information that we could benefit from as humankind could be sitting here all around us.
If you were a young scientist, you need to have some sort of hope that you can contribute something. It's not all known and you're just picking up the last crumbs off the table. There's actually a lot out there that we don't know.
To actually find a hidden rainforest, which turns out to be the largest in southern Africa, shows that we don't have all the answers and we don't know what's out there. You're always asking questions. As soon as you think you have the answers, and new questions, new doors open. That's the beauty of life.
There we go. Very nice. So, it's a more serious business, the use of technology in wildlife crime. So, this is an example of a court case I was involved with in southern Malawi. My last job was a technical advisor to the government of Malawi as their biodiversity and protected area specialist, and this is one of the national parks I was working in trying to improve management in. We came across a very large commercial logging operation deep inside Lengwe National Park where there were no roads on the Malawi side. Wildlife crime is a big business these days in millions and billions of dollars, generally targeting commercially viable species often involved with Chinese medicine and destined for the Asian market. So we can use a whole series of technological tools in here, but certainly remote sensing and GIS and spatial racial databases play a big part, as you'll see in a minute. But we can use drones, DNA fingerprinting as well. So the arrest. So deep inside Lengwe National Park, 7 game scouts came across this massive commercial operation. They arrested 35 illegal loggers over 6 sites, which include Portuguese, Chinese, Mozambican and Malawian, and we confiscated $500,000 worth of equipment. There were no roads where this arrest was made, so these 7 game guards had to get the 35 people they had arrested and all the $500,000 worth of equipment, which you'll see in a minute, through the African bush, down dry river beds and stream beds, up and over hills and mountains, basically back to park headquarters. That in itself is worth a documentary. I was brought in as a state witness for the government of Malawi for the prosecution, and my job was to try and estimate how much wood they had actually extracted. It was a 7-month court case with over 40 court appearances. Here we can see some of the accused on their way to the cells, and here we have the Portuguese and the Chinese also on their way to court. This is some of the logging stuff that we took. Big stuff. This is commercial. This isn't a few trees here and there. Bulldozers, commercial forklifts, 4x4 tractors, 30-ton flatbed lorries, Land Cruisers, Hiluxes. This operation was massive. They'd been at it probably for a couple of years. But as we're looking at a massive area, something like the size of North Wales, there were no roads on the Malawi side. So they'd actually taken road graders and driven them in from Mozambique to get into these part of the national park. And they were taking out Mapani. Mapani is a bit like, it's a blackwood, it's a bit like ebony, if you like. But all the ebonies have gone, so now they're concentrating on the Mapani trees. And, you know, they're so confident, they just put their initials on and they number them. And these are some of the extraction sites. There were 6, 7, 8 sites where we found felled trees. So my job was to estimate how much have they taken. And to do this, I turned to satellite imagery and remote sensing. So we knew where they were, so we could take a GPS, a global positioning system, we could get grid references, we could look down with satellite imagery from a number of years and start to compare before and after imagery. Once we could do that, we could actually look at areas which had been deforested, and we could put a polygon around it. You put a polygon around it, you can calculate the area. You then work out the average stocking density of a Mapani tree in this part of Africa, and you do that through looking at the various scientific papers that talk about Mapani. Now, the arrested people said, we weren't here last year. This is in 2016. So they said, we weren't here in 2015, which they were. We only arrived in 2016. So we said, okay, fair enough. We'll get the satellite maps from 2015 and we'll compare them to 2016. And that's what we did. And looking at these, we could then actually see areas which had trees the year before, which the trees had been removed in the following year. And this is the area which they were arrested in, so we then charged them with taking these trees. Here's something interesting. We also confiscated their phones. Every time, so I don't know if you know this, every time you make a phone call, a grid reference is logged in your phone. Every time you take a picture, a grid reference is logged in your phone. It's called metadata. You don't often see that. And using a special piece of software from Interpol, because Interpol were working with us on this one, we were able to take their confiscated phones, crack some of them are thumbprinted, we got rid of that, and then we extracted out all of the grid references from the phones, every phone call, every picture, and we got that in basically a spreadsheet of XY coordinates. I then plotted those over a satellite image or through a GIS, and I could see clusters of points emerging around the sort of 100-kilometre vicinity of the arrest sites. I also had the Portuguese house up in Portugal and everything, where they stayed, everything. So zooming into these clusters of points, just over the border in Mozambique, out popped these logging factories. So I don't know if you can see this. This is all wood. These are all rows and rows and rows of stacked wood, rows and rows and rows of stacked wood, rows and rows of stacked wood, loads of it, hundreds of thousands of logs, if not millions. This is all taken as a result of their mobile phone. In conclusion, the immediate area of deforestation was 2,000 hectares. That's what we charged them with, but they did a lot more than that. That's what we were able to pin on them, because that's when they said they arrived by their declaration in the area. At 500 trees per hectare, that equals 1 million Mapani trees. But it's not just like that. It's not just as simple as that. In order to take out this mature Mapani tree, you've got to drive a road in and get a tractor in to take it out. You destroy so much more in the process of that. You'll destroy all the young trees. You will disturb the wildlife. Anything that's breeding, for example, birds or the ecology, the biodiversity, will all be damaged, all be ruined, all be disturbed. And it goes beyond that. The ecosystem services. You're creating roads in very dusty, sandy ground, and you're pulling logs out on chains. You're disturbing the soil. And when it rains, that loose soil washes away. It goes into the tributaries, into the major rivers, and in this case, we go down into the Shiri River, where the main hydroelectric turbines are that generate the electricity for the whole of the country. They are clogged up and silted up on an annual basis, and this is one of the reasons why. So the knock-on effect of this massive industrial logging operation is far beyond the removal of the trees. But each tree is 2 cubic meters. A cubic meter, 30 pound a cubic meter in the field at source at cost. Okay? So if you have 1 million trees, that's 30 million pounds. But that's actually at the source. And as that chain goes down, goes along to delivery, the value of the wood increases. So they were found guilty on all charges: illegally entering Malawi, illegally entering a protected area, illegally destroying a protected species, of which the Mapani is, illegally possessing weapons, we said chainsaws were weapons, illegally bringing vehicles into Malawi. And they were sentenced quite leniently, really, 18 months hard labour, and the confiscation of their $500,000 worth of equipment. Basically, all equipment confiscated. It was quite amusing. The judge wanted the Land Cruiser, so I think they were on a losing streak straight away, because after the court case, we were assuming that a lot of the equipment would come to national parks, and the judge said, no, I'm having the Land Cruiser. So we let him have the Land Cruiser. But they appealed. They thought this was a bit harsh. They appealed, and it went to the High Court. And they came up in front of one of Malawi's only female judges, who doubled their sentence. So they got 3 years hard labour. So the moral of the story there is never cross a woman in power in Africa, I guess. So it was a successful. So all credit down to the game guards, the 7 game guards, because all the way along they were offered bribes to try and change their testimony in court, and they refused and they stuck to their story. Very rarely I have access to a helicopter to do a lot of the work. This takes me, the benefit of a helicopter is you can look down over large areas. It gives you that view, especially when there's no roads. Bottom left is the carcass of a dead elephant that's been poached, and so the helicopter in this case was actually very useful for picking up, poached elephants. Okay, finally, I'm going to talk to you about one of my latest sites. Now, this is Mount Lico that I ran an expedition to last year. This is where it is, and it fits into the larger landscape within this part of Africa. It's about 120 kilometers from Mount Mabo. It's a very rare example of a site that's been virtually untouched by humankind. Therefore, it's a very rare baseline. And this can be compared to other sites in the area that have had human disturbance. And then the difference between these sites in terms of the botany or the soil content, etc., can be then attributed to aspects of climate change. So it's a very important site for measuring climate change in this part of Africa, and can be used to ground truth or to fine-tune various climate prediction models. And the data that we got from Lico can then be added to the ecoregion database, like I say, to improve the accuracy of predictions. I first saw it in 2012, and what was interesting about Mount Lico is the surrounding land was heavily cultivated, and then you had this dark green basin on top of the forest. It's almost like a volcano with a basin of rainforest. It's not a volcano. The media got that wrong. So I thought, well, maybe you can't get there. It took a few years to actually organise a recce to go and see it, but in 2017 I managed to do that. There's Mount Lico in the distance.